Question 1. In the context of NetScaler high availability, Mr. Patel notices that after a failover event, the secondary NetScaler appliance does not maintain the same session persistence state as the primary. What should Mr. Patel do to ensure session persistence consistency across the hub pair? A. Enable session state synchronization explicitly between the hub nodes. B. Configure SNP addresses on both hub appliances. C. Disable TCP multiplexing on both NetScaler appliances. D. Increase the heartbeat interval to reduce failover frequency. Answer. Correct answer. A. Explanation. In a NetScaler hub pair, session persistence state must be synchronized between the primary and secondary appliances to maintain client sessions seamlessly after failover. Enabling session state synchronization ensures the persistence information such as cookies or source IP affinity is shared. Option B is about SNP addresses for backend communication and unrelated to persistent sync. Option C deals with ECP multiplexing, which optimizes TCP connections but does not affect persistent state. Option D might delay failover detection but won't solve persistence consistency. Best practice dictates enabling explicit session state synchronization to maintain consistent client experience during failover. Question 2. From the perspective of SSL flooding, Rivera configures a NetScaler vplex to decrypt incoming SSL traffic before forwarding it unencrypted to backend servers. However, backend servers fail to process the requests properly. What is the most likely underlying cause? A. Backend servers require traffic to remain encrypted for proper processing. B. NetScaler VIP is not configured with a valid SNP address. C. The SSL certificate on the NetScaler is expired. D. Backend servers have firewall rules blocking HTTP traffic from NetScaler. Answer. Correct answer. C. Explanation. SSL flooding requires a valid SSL certificate on the NetScaler VIP for decrypting incoming traffic. If the certificate is expired or invalid, SSN negotiation will fail or traffic will be malformed, causing backend servers to receive incorrect or no requests. Option A is generally false since offloading implies backend servers expect unencrypted traffic. Option B confuses VIP and SNP roles. The SNP is for backend server communication but not related to certificate validity. Option D could block traffic, but the question's emphasis on SSL flooding points to certificate validity as the critical issue. Correctly maintaining certificates is fundamental in SSL flood scenarios. Question 3. According to recent studies, when configuring load balancing on a NetScaler, ISTA1 chooses a round-robin method but observes uneven traffic distribution due to differing server capacities. Which concept should ISTA1 apply to better balance the load? A. Use persistence profiles to control client-server affinity. B. Implement weighted load balancing to reflect server capacity. C. Increase the number of service groups to distribute load. D. Enable content switching to route traffic based on URL. Answer. Correct answer. B. Explanation. Round-robin load balancing equally distributes requests regardless of server capacity, which can lead to performance issues when servers have different hardware or resource levels. Weighted load balancing allows assigning weights reflecting capacity, so higher capacity servers get proportionally more traffic. Option A relates to session stickiness, not load distribution. Option C misinterprets service groups. More service groups do not inherently improve load distribution but organize services. Option D relates to content-based routing, not balancing based on capacity. Weighted load balancing is best practice in heterogeneous environments. Question 4. Based on the information that a NetScaler appliance supports multiple IP address types, Ahmed assigns the same IP address as both SNP and VIP. What implications might this misconfiguration cause? A. Backend servers will be unreachable due to IP address conflicts. B. NetScaler will not be able to route traffic correctly, causing service disruption. C. This configuration is valid and will optimize resource usage. D. The appliance will fail to synchronize in a hub pair. Answer. Correct answer. B. Explanation. SNP subnet IP is used for communication with backend servers and management. VIP virtual IP is the address clients connect to. Assigning the same IP to both causes traffic routing confusion as NetScaler differentiates roles by IP type. This leads to incorrect routing or dropped packets, disrupting service. Option A is inaccurate because the conflict is internal, not external. Option C is false. It violates design principles. Option D is unrelated to HAR synchronization. Clear separation of IP roles ensures traffic flows properly through the NetScaler. Question 5. Within the framework of policy evaluation, ISTA-Kim developed multiple responder policies to redirect certain client requests based URL patterns. However, some requests bypass the responder policy and reach backend servers. With a plausible explanation. A. Responder policies must be bound globally to take effect on all traffic. B. NetScaler processes responder policies after load balancing decisions. C. The expression syntax in the responder policy is incorrect, causing evaluation failure. D. Responder policies apply only to SSL traffic, not HE. Answer. Correct answer. C. Explanation. Responder policies rely on correct expression syntax to match requests. An error causes policies to be skipped. If syntax is faulty, the policy won't trigger and traffic proceeds unmodified. Option A is not mandatory. Responder policies can be bound at multiple scopes. Option B is incorrect because responder policies evaluate early in the request processing pipeline. Option D is false. Responder policies are petty after it is configured. Proper syntax and testing are crucial for effective responder policies. Question 6. Considering the evidence on integrated caching, is Lopez enables integrated caching for static web content but notices no improvement in response times. What key factor might she have overlooked? A. The cache size configured is insufficient to store frequently requested objects. B. Integrated caching only works with SSL flooding enabled. C. Content switching policies prevent caching of static content. D. Backend servers need to explicitly allow caching HTTP headers. Answer. Correct answer. A. Explanation. Effective integrated caching depends on sufficient cache size to store objects. If the cache is too small, popular content may be evicted before reuse, negating performance gains. Option B is false. The caching works independently of SSL flooding. Option C confuses traffic routing with caching logic. Option D is partly true where HTTP headers influence caching, but integrated caching can override headers with correct policy. Cache sizing is a primary tuning parameter often overlooked, explaining lack of performance improvement. Question 7. Through careful analysis of system administration practices, ISTA Dyers wants to ensure seamless upgrades on a NetScaler MPX device. What is the best approach to minimize service disruption during firmware upgrade? A. Perform upgrades during peak hours when traffic is highest to stress test the device. B. Use a NetScaler hub pair and upgrade the secondary device first, then failover and upgrade the primary. C. Back up the configuration, then upgrade both appliances simultaneously. D. Disable all monitors and policies during upgrade to avoid interference. Answer. Correct answer. B. Explanation. Using a hub pair allows upgrading the secondary device first without impacting production traffic. Once upgraded, failover shifts traffic to the upgraded node, allowing the primary device upgrade with minimal disruption. Option A risks downtime during critical times. Option C upgrades simultaneously, risking total outage if failure occurs. Option D is unnecessary and may cause loss of monitoring during upgrade that doesn't minimize downtime. Following hub upgrade best practices ensures high availability. Question 8. When considering networking fundamentals, ISTA Johnson observes latency issues when connecting to backend servers through NetScaler. Upon investigation, he finds DNS resolution delays. Which of the following should he implement to optimize DNS lookup performance on NetScaler? A. Configure a SNP address specifically for DNS queries and enable DNS caching on NetScaler. B. Disable TC pips offloading to improve DNS resolution speed. C. Assign the VIP address as the DNS server for all clients. D. Increase the time to live TL value on backend servers' IP addresses. Answer. Correct answer. A. Explanation. Configuring a dedicated SNP or DNS and enabling DNS caching on NetScaler reduces repeated external DNS queries by caching responses, locally minimizing latency. Option B is irrelevant as TC pip offloading affects packet processing, nor DNS. Option C incorrectly uses VIP as a server, which is invalid. Option D deals with IP caching, not ENS records ETL, and changing TTL on servers does not affect NetScaler DNS caching. DNS caching and proper SNP usage optimize name resolution performance. Question 9. The general consensus is that when defining persistence methods is new and is unsure whether to use source IP persistence or cookie-based persistence. Given a scenario with many clients behind a NAT device, which persistence method would be more reliable? A. Source IP persistence, because it is simpler and requires no server configuration. B. Cookie-based persistence, as it uniquely identifies client sessions despite NAT. C. SSL session persistence, to leverage encrypted session details. D. Service group persistence, to balance load dynamically. Answer. Correct answer. B. Explanation. Source IP persistence fails with many clients behind NAT because multiple clients share the same IP, leading to incorrect affinity. Cookie-based persistence issues unique cookies per client, reliably maintaining session affinity even when IPs are shared. Option A is unreliable in NAT scenarios. Option C can work but requires SSL inspection and client cooperation. Option D is not a persistence method but related to load distribution. Cookie persistence is preferred in NAT-heavy environments. Question 10. In light of recent developments, Mr. Brown needs to troubleshoot a NetScaler VPX experiencing frequent TCP connection resets. Which action is most aligned with best practice to isolate the root cause? A. Disable TCP multiplexing to check if it causes connection instability. B. Increase the TCP window size to handle more data per packet. C. Bind additional SSL certificates to reduce TLS overhead. D. HTTP rewrite policies to monitor header changes. Answer. Correct answer. D. Explanation. TCP connection resets often arise from protocol or content handling issues. Enable HTTP rewrite policies to monitor or modify headers helps identify malformed or unexpected headers that cause resets. Option A might help but is more a workaround than diagnostic. Option B tweaks throughput but doesn't isolate root causes of resets. Option C relates to SSL overhead, irrelevant TCP resets. Systematic policy use to inspect and control HTTP traffic is best practice in troubleshooting connection issues. Question 11. Given the circumstances, Isatoris configures a NetScaler SDX device with multiple VEX instances hosting different applications. She wants to ensure resource isolation but notices one VEX affecting the performance of others. What is the most effective way to guarantee resource allocation on SDX? A. Assign dedicated CPU and memory resources to each VX instance via CX resource pools. B. Use a shared SNP address across all VPX instances to simplify management. C. Enable global load balancing across the VX instances. D. Configure all VX instances to use the same VLAN to avoid routing conflicts. Answer. Correct answer. A. Explanation. SDX platforms host multiple isolated VX instances on shared hardware. Resource pools allow allocating specific CPU and memory resources PPPX to prevent noisy neighbor issues and ensure predictable performance. Option B undermines isolation by sharing SNP, which is discouraged. Option C refers to distributing traffic, not resource isolation. Option D risks VLAN conflicts and does not control resources. Proper SDX resource management is critical to maintain performance and isolation. Question 12. Through the lens of persistence configuration, ISTA-SYNC notices users are being redirected to different backend servers mid-session. Is current configuration uses source IP persistence? What is the likely cause, and what persistence method should he switch to for better reliability? A. Users behind NAT share IP addresses, a switch to cookie-based persistence. B. Session timeout is too long, shorten persistence timeout for source IP. C. Source IP persistence requires SSL flooding, enable SSL float on NetScaler. D. Use TCP sequence number persistence to track sessions instead. Answer. Correct answer. C. Explanation. Source IP persistence alone may not ensure session continuity unless SSL flooding is enabled. Encrypted traffic hides client IP info. With the SSL flood, persistence fails, causing session drops or switching servers. Option A is generally correct, but less relevant if SSL is not offloaded. Option B affects timeout but not underlying persistence. Option D is a niche approach rarely used. The key concept, persistence methods depend on traffic inspection capabilities like SSL float. Question 13. Under the assumption that a NetScaler administrator wants to implement load balancing for a backend service with uneven server capacities, Mr. Ahmed decides to use least connections. What is a limitation of least connections load balancing that he should consider? A. Least connections does not account for server weight or capacity differences. B. It requires persistence profiles for proper operation. C. It is not supported on VEX instances. D. Least connections can only be applied to SSL virtual servers. Answer. Correct answer. A. Explanation. Least connections distributes traffic to servers with the fewest active connections but does not consider differences in server capacity or weight, which can cause overload of weaker servers. Option B confuses persistence with load balancing logic. Option C is false. The EU puts least connections. Option D is incorrect. Load balancing methods apply across protocols. To handle uneven capacity, weighted least connections or weighted round robin are better. Question 14. When analyzing system administration, Mr. Garcia performs a backup of his NetScaler configuration but finds the backup file is incomplete. What is a common reason for incomplete backups on NetScaler? A. The backup was taken without including SSL certificates and keys. B. NetScaler does not allow backups on VEX platforms. C. The configuration contains syntax errors blocking backup completion. D. The backup file was saved using the CLI instead of GUI. Answer. Correct answer. A. Explanation. NetScaler configuration backups exclude SSL certificates and private keys by default because they are stored separately for security. If the administrator expects a full backup including certificates, this causes confusion. Option B is false for ELA's backups. Option C would prevent saving configuration but is less common. Option D is irrelevant. CLI or GUI backups are functionally equivalent. Best practice includes exporting certificates separately when performing disaster recovery preparation. Question 15. During the process of configuring monitors, Lee creates a custom HET monitor for backend health checking but notices inconsistent results. What is a critical factor to consider when designing monitors for backend services? A. The monitors send and receive strings must exactly match the backend server's response. B. Monitors should always be bound to the VIP address instead of services. C. NetScaler automatically retries failed monitors without configuration. D. Monitor frequency should be set to the maximum interval to reduce load. Answer. Correct answer. A. Explanation. Custom monitors send a probe string and expect a specific response. If the received string does not exactly match the backend's response, the monitor may falsely mark the service as down, causing uneven traffic distribution or failovers. Option B is incorrect. The monitors bind to services or service groups, not VIPs. Option C is partially true but requires explicit retry parameters. Option D risks delayed detection of service failure. Correct monitor design requires precise probe response alignment. Question 16. With respect to NetScaler IP addresses, Mr. Johnson configures a SNP on the appliance but backend servers still cannot communicate with NetScaler for management tasks. What is a likely reason? A. The SNP is not in the same subnet as the backend servers, preventing routing. B. VIP addresses must be configured instead of SNP for backend communication. C. NetScaler requires a separate NSIP address for SNP to function. D. SNP addresses cannot be used for management communication. Answer. Correct answer. A. Explanation. SNP subnet IP is used by NetScaler to communicate with backend servers, and it must be in the same subnet or properly routable to those servers. If SNP is configured in a different subnet without routing, communication fails. Option B misunderstands VIP purpose. VIPs are client-facing. Option C is false. SIP is separate for management, but SNP functions independently. Option D is incorrect. SNP facilitates backend management communication. Proper subnet alignment is essential. Question 17. Considering the evidence on rewrite policies, Mr. O'Connor wants to modify HTTP headers for security purposes. Which best practice should guide his implementation of rewrite policies? A. Ensure rewrite policies are bound at the earliest possible point in the request flow to avoid conflicts. B. Rewrite policies can only add headers, not modify or remove them. C. Rewrite policies require SSL offloading to function. D. Apply rewrite policies globally to cover all traffic regardless of context. Answer. Correct answer, A. Explanation. Applying rewrite policies early in HTTP request processing pipeline allows modifications before other policies or processing stages, reducing conflicts or overwrites. Option B is false. The rewrite policies can add, modify, or remove headers. Option C is incorrect. Rewrite policies work with both encrypted and unencrypted traffic but may require SSL flow to inspect headers. Option D can cause unintended consequences and is not best practice. The policies should be scoped carefully. Strategic binding improves policy effectiveness. Question 18. To what degree does the choice of load balancing method impact failover and session persistence in a NetScaler environment, as illustrated by Ista Bennett's troubleshooting scenario where users lose sessions after failover? A. Load balancing method indirectly affects failover only if persistence is misconfigured. B. Load balancing methods are irrelevant to failover behavior. Only hard configuration matters. C. Certain load balancing methods maintain persistence better during failover. D. Load balancing method must match SSL certificate type to maintain persistence. Answer. Correct answer, C. Explanation. Some load balancing methods inherently support better session persistence during failover. For example, methods that maintain connection affinity or use consistent hashing can reduce session loss. Option A underestimates load balancing impact. Option B overlooks interaction between load balancing and persistence. Option D incorrectly associates load balancing with SSL certificate types. Selecting load balancing methods that complement persistence settings is critical for session continuity during failover. Question 19. In a modern context of NetScaler platform selection, Zhao is evaluating AX appliances. She wants to deploy multiple isolated NetScaler instances with dedicated hardware resources. Which platform should she select? A. SDX, because it supports multiple isolated VEX instances with dedicated resource allocation. B. VPX, because it runs on physical hardware and offers resource isolation. C. MPX, because it is a virtual appliance suited for multi-tenancy. D. VX, because it provides hardware acceleration not available on SES. Answer. Correct answer, A. Explanation. SDX appliances are physical devices that host multiple VEX instances as isolated virtual appliances with dedicated CPU, memory, and networking resource. VEXA, a software-only virtual appliance and cannot guarantee physical resource isolation. MPXA, a physical appliance but does not support multiple isolated VEX instances on the same hardware. Option D is incorrect. Run virtualized without hardware acceleration that MPX can provide. SDX is the recommended platform for multi-tenancy with guaranteed resources. Question 20. During the course of content switching configuration, Mr. Evans wants to route incoming HTTP requests based on URL paths. Which of the following statements best reflects the proper use of content switching in NetScaler? A. Content switching policies can evaluate HTTP headers and URLs to route traffic to different backend services. B. Content switching is limited to SSL traffic and cannot inspect pair HTTP. C. Content switching requires the use of SNP addresses exclusively. D. Content switching policies are applied globally and cannot be bound to individual virtual servers. Answer. Correct answer, B. Explanation. Content switching can inspect by HTTP traffic, but for encrypt HTTP's content switching, SSL offloading or bridging must be configured for inspection. If SSL offloading is not enabled, NetScaler cannot inspect URL paths in encrypted traffic, limiting content switching capabilities. Option A is true but incomplete with the SSL offload context. Option C confuses IP roles. The SNP is unrelated to content switching binding. Option D is false. The content switching policies bind to content switching virtual servers specifically. Correct SSL handling is essential for content switching AT. Question 21. In the context of NetScaler SSL flooding, is the client configures SSL flooding on a VIEP, but clients report certificate errors. What is the most likely cause of this issue? A. The SSL certificate is not bound correctly to the VIEP virtual server. B. The backend servers do not have valid SSL certificates installed. C. The SNP address is misconfigured, blocking SSL traffic. D. The SSL key file is missing from the NetScaler appliance. Answer. Correct answer, A. Explanation. For SSL offloading, the NetScaler VIA must have the correct SSL certificate and key bound to it to present to clients during SSL handshake. If the certificate is missing or incorrectly bound, client sees certificate errors. Option B affects backend communication but not client SSLers since traffic is decrypted at NetScaler. Option C involves backend communication, not client SSL handshake. Option D would cause failure, but missing key is usually caught during binding. Proper SSL binding on VIEP is essential for client trust. Question 22. Taking into account monitoring and troubleshooting best practices, Isa Patel notices intermittent failures in service health checks, but the backend servers are healthy. What should she investigate first on the NetScaler? A. Monitor timeout and retry settings causing premature failure detection. B. Backend server firewall blocking out traffic from NetScaler. C. SNP address conflicts with VIEP address ranges. D. Load balancing method configuration is incompatible with monitors. Answer. Correct answer. D. Explanation. Certain load balancing methods may conflict with how monitors assess backend health. For example, some persistent settings or sticky load balancing may skew monitor results. Option A is important but less likely if failures are intermittent. Option B could cause backend unreachability, not intermittent false failures. Option C, IP conflicts are serious but usually cause constant failure. Troubleshooting monitor load balancing interactions is a key step. Question 23. When evaluating system configuration, Wu finds that the NetScaler appliance's time is out of sync with corporate NTP servers. What are the implications of incorrect system time on the NetScaler? A. SSL certificate validation and authentication mechanisms may fail. B. Load balancing algorithms will distribute traffic unevenly. C. SNP and VIEP addresses will become unreachable due to time drift. D. Content switching policies will not evaluate correctly. Answer. Correct answer, A. Explanation. SSL certificates and security protocols depend on accurate system time for certificate validity periods and timestamp-based authentication tokens. Incorrect time leads to SSL handshake failures or rejected credentials. Options B, C, and D do not depend on system time directly. NTP synchronization is a critical best practice to ensure security and operational integrity. Question 24. Considering the relationship between policies and expressions, Ising attempts to create an advanced expression for a content switching policy, but it does not behave as expected. What is a common mistake that could cause this? A. Using classic expression syntax instead of advanced expression syntax in the policy. B. Binding the policy to the wrong virtual server type. C. Configuring multiple monitors instead of a single one. D. Forgetting to enable SSL offloading on the VIP. Answer. Correct answer, B. Explanation. Content switching policies must be bound to content switching virtual servers. Binding them to other virtual server types like load balancing or SSL servers leads to non-functional policies. Option A is less common because NetScaler validates syntax. Option C is unrelated to policies and more about health checks. Option D affects SSL inspection but not policy binding. Correct virtual server binding is essential for policy effectiveness. Question 25. During the process of configuring integrated caching, Mr. Patel observes that the cache is frequently flushed despite no configuration changes. What best practice could prevent this? A. Configure appropriate time-to-live (TTL) values on cacheable objects. B. Disable SSL offloading to avoid cache invalidation. C. Increase the number of service groups to distribute caching load. D. Enable caching only on SNP addresses. Answer. Correct answer, C. Explanation. Increasing service groups allows the NetScaler to distribute cache load and reduce cache flush frequency due to capacity constraints or conflicts. Option A is critical but relates to cache expiration, not flush frequency. Option B is irrelevant. ASL loading does not inherently cause cache flush. Option D misunderstands caching scope. Caching applies to traffic passing through VIPs. Proper architecture with multiple service groups optimizes caching stability. Question 26. In a modern context of NetScaler networking fundamentals, Mr. Lewis is troubleshooting to CPIP connectivity issues. Which NetScaler IP address type should he verify is correctly configured to communicate with backend servers? A. SNIP, because it acts as the appliance's IP for backend server communication. B. VIP, as it represents the external client-facing IP address. C. NSIP, which is used for management access only. D. Subnet IP, which is deprecated and no longer functional. Answer. Correct answer, A. Explanation. SNIP subnet IP is the IP address that NetScaler uses to initiate communication with backend servers. Ensuring SNIP is properly configured and routable is vital for backend connectivity. VIPs represent front-end addresses for client connections. NSIP is management interface IP unrelated to backend traffic. Subnet IP is another name for SNIP. It is not deprecated. Correct SNIP configuration is essential for backend communication. Question 27. While examining the consequences of SSL flooding, Isa Daniels noticed that EP usage spikes on the NetScaler during peak hours. What is a recommended strategy to mitigate this? A. Use hardware acceleration capabilities on MPX platforms. B. Disable SSL flooding to reduce CPU load. C. Increase monitor frequency to detect failures faster. D. Assign VIP addresses with multiple SNPs to balance load. Answer. Correct answer, C. Explanation. Increasing monitor frequency increases monitoring overhead and CPU usage, so it exacerbates CPU spikes and is not recommended. Option A is a best practice because hardware acceleration offloads SSL encryption from CPUs, reducing load. Option B defeats the purpose of SSL flooding and shifts CPU load back to backend servers. Option D confuses IP assignment roles. Utilizing hardware acceleration is the preferred solution. Question 20. A key distinction between content switching and load balancing, as Istis Singh discovers, is that content switching A. routes traffic based on content within the request, while load balancing distributes traffic based on server availability. B. requires SSL offloading to function properly, and like load balancing, C. can only be configured on APX appliances, not EXEX. D. uses SNP addresses exclusively for client communication. Answer. Correct answer, A. Explanation. Content switching directs traffic based to HEP content, such as URL or headers, enabling granular routing. Load balancing distributes traffic based on server health and availability without content inspection. Option B is false. Content switching can work with the SSL offloading of HEP but needs SSL offload to inspect HEE. Option C is false. Content switching is supported on all NetScaler platforms. Option D is incorrect. SNP is for backend communication, not client. Understanding routing granularity is key. Question 29. From a practical standpoint, Mr. Kumar is configuring monitors to check backend server health. He wants to monitor both ECP connectivity and HEP service availability. What is the best approach? A. Bind both a unitron and HTTP monitor to the service. B. Use on a HTTP monitor, since it implicitly checks TCP connectivity. C. Use a custom monitor that sends TCP probes over TCP ports. D. Configure monitors at the VIP level rather than services. Answer. Correct answer, B. Explanation. HTTP monitors inherently check TCP connectivity as a prerequisite for HTTP response if the EP for HTTP monitoring fails to. Using an HTTP monitor simplifies monitoring while covering both EEP HTTP layers. Option A can cause redundant checks but is sometimes used for complex setups. Option C is unnecessary for standard HTTP health checks. Option D is incorrect because monitors bind to services, not VIPs. Simplifying with HTTP monitors is best practice. Question 30. When faced with a scenario where multiple write policies are applied, Is Young notices conflicting header modifications. How should she resolve this? A. Prioritize and order rewrite policies carefully, testing effects in sequence. B. Disable all rewrite policies and use responder policies instead. C. Apply rewrite policies globally to ensure uniform behavior. D. Use content switching policies to replace rewrite functionality. Answer. Correct answer. D. Explanation. Content switching policies route traffic but do not replace header modification capabilities. This makes D an incorrect solution. The best way to manage conflicting rewrites is A. Where policies are ordered and prioritized explicitly. B. Is unrelated. Responder policies have different functions. C. Risks unintended global changes. Proper sequencing and testing of rewrite policies ensure predictable behavior.